name all this platform as a house. And then the type is a residential. See? Immediately we can see house 6 meter, house 5.6 meter. You can choose to show or unshow it. I say I don't want to show the mark, I can say no. So only remain 5.7 meter, or I don't want to show the height, say no. Okay, so we can easily edit lah. And the platform here also I will change to house, residential. Maybe this one I call it house 2. That means I divide into 2 groups. First group of the volume is for house. Second one is for house 2. Okay, so the rest is road. These 2 platforms is road, so I call it road. And this one I call it kawasan lapan. Okay. We can add more platform. All this is import from AutoCAD. If you have a ready data, if you don't have, we can open up the AutoCAD, then we can snap it and model the platform. Then I model another one platform for this row of building. Okay. And then we can check. The level is 5.3, 5.3, 5.6, 5.6, 6, 6. That means we have 3 groups. So we can divide into 3 to break it up. We can break it up. Okay. Okay, so we can see the first one, maybe I name it as house also, house 3. And then the type is residential. Second one, or we can select together, house 3. Change back to the black color. Okay, because I cannot see in the screen, not very clear in the screen for a white color view. Okay. So this one, the height is 5.3, and then 5.6, and the last one is 6 meter. Okay, so that's all for the platform editing. Okay, so we can add more cut section. Let's say I add another cut section from this point to this point. Okay, and then we can extend the cut section. So extend up to here. Then we can add more. Add cut section. Let's say up to here. And then every interval 10 meter. Okay. And then I will extend again the cut section. Same, I add more cut section up to here. Interval 10 meters. So immediately we get all the cut section done. Okay, you can see all the cut section. It's done. Cut 1, cut 2, cut 3. Need to turn off the light. Turn off some light. Okay. Okay. So behind can see, clear enough? No response. Okay. So fall asleep. No. Okay. So come back to the input. So I think that's all for the input part. We can analyze. Okay, I will skip the grid system. Actually, our software we have DTM and the grid. Okay, so if I skip the grid, we can tell the program only DTM. Okay, then we click OK. So finish. So we can see the meshing. Okay, so this is the thin method DTM meshing. Okay. You want to view the cut section? And open up. See where we already cut. Okay. Then we can view the 3D. Okay. It's quite flat. This project quite flat. So we can call out the contour. Also, we can change the amplitude. Okay. You can see better. This is the highest area. And here is also high area. Okay. Okay, then for the next one is our 3D proposed level view. Okay, so this one we can view the existing level and proposed level together in 3D. And we can see very clear where is our Kawasan Lapang platform, where is our road platform, where is our housing area platform. See this green color, our Kawasan Lapang. So the same, we can change the amplitude. So this is our highway. This is highway and the internal road. Okay. That's all. Come back to the Excel report. So we can see we can apply the square and string factor, get the bank cut, expanded cut. So bank cut times 1.1 factor, kind of expanded cut 30,000 something. Okay, and then the fill. So the export or import. So if the cut more than fill, that means export. That means it's positive. So if negative, that means import. Okay. And we have the detail calculation. So depends on how many group of the platform name we put in. So divide into groups. Okay. I think today half of the audience is our client, our user. So you all know about this. This is similar with your existing software. Okay. So the next one is the drainage. So it's the same. We'll integrate together. So the platform already here. Okay, I can only turn on the platform. Okay, so this is the platform only. If you want to show the tracing, you can open up to show the tracing file. Okay, so before this, we can check the parameter setting. So we have 7 types of drainage, the channel design. Half round, box drain, V-shape, broad drain, pipe covered, box covered, and trapezoid. Okay, so we can set a rules for the program to do the iteration. Okay, let's say for the box. So we set 600 times 300 is the first iteration data. So if this one cannot pass, the software will jump to the second one. The software won't propose 600 times 500 because it's not here. Okay, so we can always edit or we can add more. Okay. Half round is depends on our W2. Okay. So if the program choose W2 300, so go to the iteration W2 300. That means H1 is 2 times the ratio, so become 600. W1 also becomes 600, 2 times. Okay, so the rules we can set. We can change this one. I want to have 1.5 ratio, also can. Okay, then that means 300, 1.5, 450. Okay, so we can set the rules in the parameter, or we want to use the default setting, also can. Okay, I think most of our user is using default. Okay. The rest is the gradient setting. Even level, covered, velocity, cascading drain. So true, that means we want to have cascading drain if the gradient cannot pass. So if false, that means after it cannot pass, we will propose a drop sum. Okay, and then the cascading drop. So we can add it. Let's say I want to choose 150 millimeter. And then for the drainfall time, we can choose the method. Method is a constant average velocity, that means 1 meter per second. Or we can choose Manning's equation, calculate by using Manning equation. And then this is our long section setting, the horizontal and vertical skew. Okay. And the rest is the coloring, text height, all this simple setting. Okay, so that's all. So come back to the input. So we can start to model out the drainage network. Okay, first I model here. Okay, so we can see after we key in the node, immediately the ground level will appear because we read from the platform. Okay, so you can see 3.2. So invert level is 0 because we haven't analyzed. And then this is the default value for the drainage. After we analyze, this also will change. Okay, so I continue on. Okay, let's say we have another network join in. Okay, so very simple. After that, we can add in our catchment. I think I can turn off the show tracing. Okay, let's say I have one catchment is here. This is my first catchment. For the drain number, you can choose the drain number 1. Okay. Then this is for the overland streetfall pad, the length. We can always adjust. Okay. Then I adjust to the furthest point or what. We can always adjust. After you adjust it, automatically will calculate the L for us. And the S, the sloping, also will automatically calculate. Okay. Later I will show you the calculator. I think the aircon is off. Suddenly. Check. To check. It's very hot actually. Okay, so this is my second catchment flow into drain number 2. Okay, then my third catchment assigned to drain number 3. And then another catchment assigned to the drain number 4. And then this catchment I will assign to drain number 5. Okay. Let's say this is a impervious area for drain number 5, the impervious area catchment. So we can add in another catchment, let's say in the Kawasan Lakang. So this is a pervious area catchment flow into drain number 5 also. Okay, so we have more than one. We can have more than one catchment flow into one drain. Okay, so when we turn off the platform, so we can see only the drainage network together with the catchment. Okay, so we can go to the spread input. Okay, so ground level is automatic pickup. Just now our road level is 3.2, the internal road. It's not the highway. Highway will have different value. Okay, so internal road I preset to 3.2, so automatic import in. We also can edit, let's say for this last point, node number 5, I change to user define yes, so I can fix a value like 1.2 ground level. Okay? If I say no, the program will update. If I move the node, the program will follow the value, the ground level value of the graphical. Okay, then the invert level also the same. We can say iteration yes. That means the program will auto calculate the invert level for us. And if we say no, then we can fix a value for the invert level. Normally we will say yes for all. For the first time iteration. First time